Buenos dias, Chargeritos. Before we get into today's lesson, we're going to do a little review from yesterday. Remember, we talked about the different layers of the Earth's core. We start off with the crust, which is the thinnest layer. It's what we walk on, what we build things out of. It's a solid. It's made of mostly rocks and dirt. All right? That's the thinnest, the crust. The second is the mantle. Remember, we said that's that semi-solid state of matter. That's the second layer. It's also extremely hot because the deeper you go, the hotter it gets. And that moves and turns with the earth as the earth rotates and moves. So it's not a full solid, okay? Its part has some liquid to it. Then the third layer, the outer core, that's all liquid. That's magma. That's lava. That's what flows out from underneath us. When it shoots out a volcano, that's what comes out. And we know how old the Earth is because all the old rocks from the core and over the billions of years the Earth has been forming, all that shoots out when a volcano erupts. The outer core is liquid. And the core, the inner core, that's pretty much the lifeline of the Earth. That's the nucleus. If you think of a cell, that's what drives the Earth. That's what keeps everything going. That's what keeps the Earth turning. That is a solid. It's made of mostly different kinds of metals. That is the hottest part. Remember, it's about 2,000 degrees hotter than the sun, the surface of the sun. So, review. You're going to answer these questions to the side. What layer of the Earth is the thinnest? What layer of the Earth is the thickest? And as you travel from the outside of the Earth to the inside, the temperature what and the pressure what? All right, today's topic, magnets. Today, I can explain where the Earth's magnetic field is the strongest and discuss why it exists. Notes. Remember, guys, you need to get this down. Today, everything's a little backwards. The red is going to be your term, and the green is going to be the definition. First one, Earth's magnetic field. Behaves as if the planet has a bar magnet inside of it. Okay? So there's an imaginary big magnet that is inside the Earth that moves with the Earth and creates a magnetic field around it. We have a north and a south pole. Okay? We see right here. But if you notice, it looks a little different, doesn't it? South is on top and north is on bottom. Well, that's because of this. The geographic north is actually the magnetic south. When this was all discovered, we didn't really know any better. We didn't know exactly how it worked because it was discovered in the 20s or 30s. All right, the core magnetic field. So what they thought was north, well, it really isn't. But our geographic north is technically the magnetic south. So whenever you see this again or you have to answer it, just remember, just do the opposites, okay? You can relate it like this. When Columbus sailed to America and you saw the native people there, he'd call them Indians because he thought he discovered the continent of India. But little did he know that he discovered the continent of America, okay? And it hasn't changed since then. We just still call them Indians. So in this particular case, north and south are flipped as magnetic poles, okay? So how can we detect magnetic fields? We use a thing called compasses. A compass becomes magnetized. When it's rubbed with the magnet, it will then align to the magnetic poles, all right? So if you're lost in the woods, people use a compass to find out where they're going. And a magnet always instinctively points north because it's pointing to the strongest magnetic field, all right? But it's pointing geographic north, but it's really pointing to a magnetic south. So how do we make a compass? Well, we're not going to learn about that. Hold up. Okay. So let's do it step by step. Get this down. There's important notes. The strongest force of the field. Where is the strongest part of magnetic field? The outer core. The strongest force of the field is found at the poles. The outer core, that's the convection of liquid iron, plus the rotation of the Earth produces the field. I'll break this all down for you. So, first things first. The strongest forces of the field was found at the poles, right here. You get your North Pole, your geographic north, and your geographic south. Look how close those lines are together, right there. You see that? That's where it's strongest. That's why a compass will always point to those poles, because it produces the strongest field of magnetism. Now the outer core, or convection of liquid iron plus the rotation of the Earth, produce the field. Remember, the Earth is on a tilt and it's constantly rotating. Every day, every second, it's rotating. It's because the core generates the power. In the outer core, all that hot liquid iron and plus the rotation of the Earth, well, that charges all the electrons. And so it creates a strong magnetic field. And that's why we have it. And you see how it expands out like that? Well, that's our whole field. It's like a laser shield. It's our protective force from space radiation. The sun gives off a lot of nuclear radiation, and it shoots waves at us of radiation every hour, every day. And our magnetic field allows those waves to go safely over us. If we didn't, we'd all be dead. Okay? So these, right here, this magnetic field, that's a real life force field against space radiation that we need in order to survive and for our planet to function the way it does. And the strongest magnetism levels are at the poles. All right. Thompson out. Peace.